Hello and welcome to this C++ in Action webinar. My name is Mannarino and I'm one of the Embarcadero software consultants. This session will focus on helping you migrate your legacy C++ Builder apps to Unicode. So at Embarcadero, we are often asked to help migrate legacy C++ Builder code to the current versions, including C++ Builder 10 Seattle. So over time, we have learned tips and techniques to help you with your Unicode migration. Now, once you get a handle on these tips and techniques, developers have reported that it didn't take long to convert their applications, and the applications migrated fairly smoothly. Now, a major benefit from migrating to Unicode is to get the full benefits of internationalization. Plus, you'll gain all of the significant features and enhancements in the newer versions of C++ Builder, like Windows 10 support, so you can quickly and easily update your VCL and FireMonkey apps to Windows 10 with the new Windows 10 VCL controls and universal Windows platform services. And you can create FireMonkey multi-device apps and deploy to Windows, macOS 10, Android, and iOS, all from the same single C++ project. So that's cool. And we also double the available memory for large projects. And you also have C++11 and the Clang-based C++ compilers, just to name a few of the new features. For the agenda, we'll look at working with Unicode in C++ Builder. So as you know, for string data type, C++ Builder offers several choices. So your code can use C style characters and strings, or C++ string objects, or VCL string objects. And each of these has its own set of Unicode variations. Also, the Windows API provides both ANSI and Unicode variants. We'll look at the new C and C++ data types for C style strings, such as wchar _t and char16 _t and char32 _t. We'll look at the new Unicode VCL string classes. So starting with Rad Studio 2009, the VCL offers several string classes which support ANSI, UTF-8, and UTF-16 encodings. We'll see that most member functions of these new VCL string classes operate just as they did before a Unicode string class. We'll also look at the _teacher maps to option, which determines whether or not the Unicode preprocessor macro is defined, and that determines whether you get the ANSI variant or the wide string UTF-16 variant. We'll also look at the standard Windows header, the tchar header file that includes macros designed to let you write code that compiles as either ANSI or Unicode. And we'll see how this can help when converting code one portion at a time. So we'll see how this header is valuable to write character-wide agnostic code that can compile as either ANSI or Unicode, and that lets you prepare for the migration in your previous versions of C++ Builder without breaking compilation. We'll look at converting text to and from Unicode because we need to know how to convert between the various Unicode encodings and the various ANSI encodings. And we'll see that the two easiest ways for doing this are using the Windows API and using the VCL. And lastly, we'll also look at how to load and save Unicode characters to files, because you can use Unicode characters with VCL components like the tmemo, the tlist box, the tcombo box, the tedit box, etc. So we need to know if any modifications are needed to our C++ Builder programs to handle Unicode characters for these components. For an introduction to Unicode in C++ Builder, since C++ Builder 2009, we now have full Unicode support throughout both the VCL and the runtime library. And Unicode is critical for internationalization. Now, migrating to Unicode will be easier than you think. And a first thought to consider is that you may not have to migrate to Unicode to use C++ Builder. So why is this, you might be asking? Well, C++ is a diverse language permitting the use of many libraries and several programming paradigms. And while your code that uses the VCL does need to be Unicode aware, your code that uses the C runtime library, the software template library, or the Windows API, for example, can continue to use ANSI and only convert to Unicode when passing data to or from the VCL. Now, a complete migration to Unicode is necessary to gain the full benefits of internationalization, but migrating only the VCL portion of your code can simplify the task of upgrading to 10 Seattle while letting you gain the significant benefits offered in the current 10 Seattle release. So whether you decide to make your entire application Unicode aware or to upgrade only the portions that interact with the VCL, we're going to discuss several C and C++ development techniques that can make the task much easier. For a C++ builder Unicode migration resource to start with, if you have not read it already, take a look at this Migrating Legacy C++ Builder Apps to C++ Builder 10 Seattle blog post on our Embarcadero community website. It provides tips and techniques to help you with your C++ Builder migration working with Unicode. And once you get a handle on these tips and techniques, our C++ Builder customers have reported it didn't take long to migrate their applications. To move your legacy C++ Builder projects to 10 Seattle, you have a few options. So option 1 is to just open your old project files and/or project groups in C++ Builder, and the IDE will update the project file, rebuild the project, look at any compile and/or link errors or warnings and fix them as needed. Or you have option number 2, which is what I recommend. Don't let C++ Builder convert your old projects. Instead, copy your source files into a new folder, and then in C++ Builder 10 Seattle, create a new project of the same project type, and then start adding your source files to the new project. So it is a little more effort at first doing it this way, but it's going to save you a lot of time later on. Let's go into C++ Builder 10 Seattle and take a quick look at a typical Unicode migration item. So here I'm using C++ Builder 10 Seattle subscription update 1. So I created a new VCL forms application and I copied in its source code. When I go to build the application, I get some errors. Looking at the errors, it tells me that I cannot convert char const to const y_char_t. So this tells me Unicode conversions may be needed, like ANSI characters need to be converted to Unicode. So all VCL functions that used to accept arguments of type char asterisk, for example, application message box, now require a y_char_t asterisk. VCL object properties that returned ANSI string now return Unicode string. So for example, the caption property of a T label. So here's an example where you cannot blind cast. So a char asterisk star is not a y_char_t asterisk. So to resolve this Unicode conversion error, we can use a Unicode string with a C_string function, and that will return for us a y_char_t. And the C_string function gives us the current value of the string object, and Unicode string is a new class containing 16-bit y_char_t data in the UTF-16 encoding. So to resolve this error, for both the open string and the URL string, I'm going to use the Unicode string with the C_string function, and that's going to return for me a y_char_t. So now if I build and run this application, it should work fine. And if I click on the label, that's our URL string, it should open up our web browser and go to Embarcadero.com. So all of that works great. Let's take a step back and look at Unicode in C. So here is sample C code with examples of Unicode literals, escape codes, and preprocessor macros. So C developers are used to using string header functions such as stir length and stir copy and stir cat to manipulate C style strings. In Unicode, there are corresponding functions for manipulating C style y_char_t strings. So most y_char_t functions are defined in both the wide char header file and in the traditional header file, string header for plain string manipulation and standard IO header file for IO, etc. Let me take this code and drop it into 10 Seattle and we'll see that it builds just fine. Let me open up this project in 10 Seattle. I have it in my C++ Unicode in C project. It's a console app. So here's the code, and if I go and build this, it should build just fine. So it builds fine, no errors, so that's fine. Right, next, let's take a quick look at Unicode in C++. And to show you this, let me do it inside of the C++ Builder 10 Seattle IDE. So here's Unicode in C++. Now, string manipulation in C++ usually involves the use of the standard string class, as well as various IO stream classes for input, output, and string buffering. Now, developers also familiar with Boost may also use classes like Boost regex or Boost format to help with string manipulation. But as it turns out, like we see here in this code, switching to the wide char _t version of these classes is quite easy. All you need to do is prefix a W to each of the class names. So this code shows sample char string code in C++ and its corresponding wide char _t code. So we see that a string becomes a wide string and a string stream becomes a wide string stream. And if we build and run this app, it should just build and run just fine. So there it is. So that all works great also. Looking at Unicode in VCL, we see that the VCL offers these 6 string classes which support ANSI, UTF-8, and UTF-16 encodings. So we have ANSI String, which corresponds to the old string class. It contains 8-bit char data in the system default code page. We have the new Unicode string, and that's a new class containing 16-bit wide char _t data in the UTF-16 encoding. Wide string still exists from previous versions of RAD Studio, and it corresponds to COM's BSTR data type. So that's the basic string or the binary string data type, and it contains a 16-bit wide char _t data, just like the Unicode string. Now, because Unicode string uses C++ Builder's own memory management and reference counting, it's often faster than wide string. So unless you need easy interoperability with COM, then you should use the new Unicode string class instead of the wide string. ANSI String T is a class template that contains 8-bit char data encoded in any code page, and the code page is given as the template parameter. So ANSI String is actually a type def for ANSI String T. Now, this requirement that the code page be given as a template parameter prevents you from using ANSI String T with arbitrary code pages at runtime. So if you need that capability, you may need to instead use the raw byte string or use one of the C or C++ string manipulation methods instead of using the VCL. UTF-8 string is an ANSI String T instantiation using the UTF-8 encoding. And lastly, raw byte string contains 8-bit char data in an unspecified code page. So the VCL will avoid applying any code page conversions to raw byte strings. It becomes the calling code's responsibility to correctly handle code pages issues. Using raw byte string can have several advantages. Since each code page is otherwise a separate compile time type, raw byte string lets you write a single routine that can handle any code page. It removes any VCL overhead of doing code page conversions itself, and it prevents possible loss of data from automatically converting text data into encodings that can't represent some characters. The good news with all of this is that most member functions of these new string classes operate just the same as they did for the old non-Unicode string classes before C++ Builder 2009. Here's a quick example on using the ANSI String T code page template to pass Unicode Cyrillic data from code page 1251 to 65001 and back to Unicode without any data loss. So that's very cool. Windows 1251 is a popular 8-bit character encoding designed to cover languages that use the Cyrillic script, such as Russian, Bulgarian, Serbian Cyrillic, and other languages. And it is most widely used for encoding the Bulgarian, Serbian, and Macedonian languages. Code page 65001 is UTF-8. Here are some useful string handling and Unicode with C++. So first, a short string occupies as many bytes as its maximum length plus 1, and the first byte contains the current dynamic length of the string, and the following bytes contain the characters of the string, and the length byte and the characters are considered unsigned values. So the maximum string length is 255 characters plus a length byte, and that gets us our string 255. For string literal prefixes, here's examples on how to use capital L, lowercase u, and uppercase U for Unicode, UTF-16, and UTF-32 string literals. Now, length is a member of Unicode string, ANSI string, and wide string in C++, and you can use string.length for the length of the string. For checking for Unicode strings, you can use system Unicode string is lead surrogate, and that returns true if the indexed element is a lead surrogate and false otherwise. Or you can use Unicode string is trail surrogate, and that returns true if the indexed element is a trail surrogate and false otherwise. With both methods, the index is an element index into the string, not a character or byte index. Looking at Unicode and Windows API, we see that the Windows API includes both Unicode and ANSI variants. So for example, if we look at the message box function, it's actually two different functions, right? Message box A, which takes ANSI strings, and message box W, which takes wide UTF-16 strings. So message box itself is a macro that resolves to message box A or message box W, depending on your preprocessor macros and project options. Now, you're also free to explicitly call one API variant or the other, regardless of your project options, simply by calling message box A or message box W directly. And other Windows API functions dealing with text or string data have similar variants. Now, which variant you get is determined by whether or not the Unicode preprocessor macro is defined. In C++ Builder, this macro is automatically defined depending on your project's options. In upcoming slides and demonstrations, we'll see how you can change the Unicode preprocessor macro using the _teachar maps to option. And we'll also see in a moment how the Unicode macro also affects the use of standard Windows TeachOurHeader file in writing code that can compile as ANSI or Unicode. And lastly on this slide, the Windows API also includes functions such as char next and char previous and compare string that are capable of dealing with complexities such as composite characters and surrogate pairs. So all of this is great. Next, let's look at the C++ data types for C-style strings. So working with Unicode introduces several more C and C++ data types for C-style strings. So I mentioned these previously under Unicode in C and Unicode in VCL, but they also apply to C++. So just to be complete, here they are again. The char 16 _ T and the char 32 _ T specifies the two new character types for holding UTF-16 and UTF-32 data respectively. The char 16 _ T values, they're written using the string literal prefix lowercase u, and the char 32 _ T, those values are written using the string literal prefix uppercase U. And lastly, C++ also has the ANSI String T code page template that contains 8-bit char data encoded in any code page, and the code page is given as the template parameter. And if needed, you can create your own ANSI string types. Let's spend some time on this _teachar maps to option in C++ Builder. In the C++ Builder IDE, this _teachar maps to option controls the floating definition of _teachar. So you have two choices. So if _teachar maps to ychar _t, this is the typical default for C++ applications that use the VCL or FireMonkey. The other option would be _teachar maps to char. And if it's set to char, this is the default for C++ applications that do not use the VCL or FireMonkey, such as C++ console applications. Before you can set this option to ychar _t, your project must have an entry point called _tmain or _twinmain. Now, new projects created with Rad Studio have these entry points by default, but imported projects might need to have these entry points added by hand. And that's another reason when you are migrating your legacy projects to the newer 10 Seattle to first create a new project, either VCL or FireMonkey, and then copy your source code into the new project. As we see here on this slide, to change this option from the IDE, it's under the Project Options C++ Shared Options, the _teachar maps to option. So if this _teachar maps to is set to char, then the Unicode preprocessor macro is left undefined and the ANSI variant is used. If it's set to ychar _t, then the Unicode macro is defined and the wide string UTF-16 variant is used. Also, when set to ychar _t, the core header file, tchar, defines the macros for Unicode builds, and in writing code that can compile as ANSI or Unicode. We're going to take a look at the tchar header file in the next slide. So, for C++ code that interacts with the Windows API and VCL, it's better off having _teachar set to ychar _t, like we see here on this slide. Let's now talk about how do you use the Windows tchar header file with Unicode. So it can be valuable to write character width agnostic code that can compile as ANSI or Unicode. So if you're planning on a complete Unicode migration as part of an upgrade to C++ Builder 10 Seattle, character width agnostic code lets you prepare for the migration in your previous version of C++ Builder without breaking compilation. And Windows provides us with this tchar header file to help with this. Depending on whether the _Unicode preprocessor macro is defined, as we just discussed in the last slide by setting C++ Builder's _teachar maps to option, this tchar header defines the following macros for Unicode builds. So tchar, which is defined as char for non-Unicode builds, or it's defined as ychar _t for Unicode builds. _t, which is removed by the preprocessor for non-Unicode builds and is defined as uppercase L for Unicode builds. So this means that you can write _t hello world and the preprocessor converts it to a char literal hello world, or ychar _t literal, and that gives us the uppercase L hello world as appropriate. And here are the other macros you get for Unicode builds from the tchar header file. So for example, we have the wide string cat to append one string to another. We have the wide string printf to write formatted output to standard out. We have the wide string get C to get the next character from a stream. And we have the wide TOI to convert a string to an integer. And macros are also provided for file and directory manipulation functions so that you can manipulate ANSI or Unicode file names as appropriate. So you can look at the source code for this include TeachOurHeader file for a complete list of available macros, and using these macros is very simple. Let's now take a look at an application to show us how to work with the _teacher maps to option and use the TeachOurHeader macros. Here's a CBuilder 10 Seattle VCL Forms application. It has 2 buttons and a T-edit box. Now in the edit box I have Unicode characters. So the CBuilder IDE is fully Unicode aware, meaning you can enter Unicode characters in the VCL controls like the T-edit or a T-list box. And you can enter Unicode characters directly for the properties of the controls, like for the text property of the T-edit or the name of the control. So if I wanted to change the name of my edit 1 to these Unicode characters, I can do that. So I can copy these characters and let me search for the name, and instead of calling it edit 1, I can replace it with those Unicode characters and the IDE will know what to do with it. So that's pretty cool. But let me put its name back to edit 1 because it's a lot easier for me to work with it as edit 1 rather than those Unicode characters. And if I needed or wanted, I could enter Unicode characters directly into the code without resorting to any escape characters. With the message box button, I'm calling the Windows API message box and I'm putting out a string, hello CBuilder 10 Seattle. You see here I'm using the TeachOurHeader macro _T, but I could have also used the _text macro. Now to be able to use this _T macro, I needed to include the TeachOurHeader file. The _T is a macro that converts 8-bit strings into wide character format. Also using the _T macro, I'm outputting the caption for the message box to say message box - literal string and an OK for the message box OK button. After that, if I have Unicode defined, meaning that I have _t char map to y char _t, then I'm going to output the text from my edit box. So if I have Unicode defined, then the text could be either ANSI or Unicode and it should output and display correctly. But if I don't have Unicode defined, meaning _t char maps to char, then I'm going to use ANSI string and do this cast using the C_string function and take the string text from the edit box. So this way, this application will work whether the code or the application I'm building is on a Unicode enabled system or a non-Unicode enabled system. Looking at my project options, C++ shared options, we see that our _teacher maps to wide char _t. So this sets the Unicode defines and the wide string UTF-16 variant is used. So now let's run this app and see what it does. Run the app. So when I click on the message box button, we display the string hello CBuilder 10 Seattle using the _T macro, and we display the message box caption message box literal string that's also using the _T macro. Now when I click the OK button, now since Unicode is defined, we output the Unicode text characters from the edit box. So since Unicode is defined, the text could be either ANSI or Unicode, and it outputs correctly like we see here. And the message box caption message box text from my edit1 text dot C underscore string also displays correctly using the underscore T macro. So that works great. Now if I go into my project options and I change the underscore teacher maps to char, and if I rerun the application, let's see what happens now. Run the app. So now this app is running with the underscore teacher maps to char. So when it's set to char, the Unicode preprocessor macro is left undefined and the ANSI variant is used. So we have an ANSI string based application here. So now when I click on the Windows API message box button with underscore teacher map to char, we see that the literal strings, the non-Unicode, display OK. So now since Unicode is not defined, the app will execute the else code and the message box will try to display an ANSI string of the Unicode characters in the edit box. So when I click the OK button, because now it's an ANSI string application, the Unicode text in the edit box displays as question marks, but otherwise the app still works OK. So what we see here, if we try and type Unicode text into an ANSI string based application, then we're going to get question marks for the output, but otherwise the app works. Let me go back into project options and let me set the underscore teacher maps to back to ychar underscore t, and then we'll rebuild and run the app and we'll see what the application message box does. Looking at the event for the application message box, here we are using the application class, which is in the VCL, and I'm going to call its version of message box. In this case, since it's the VCL, it's expecting the Unicode string, so I'm using the underscore D macro. The underscore uppercase D macro makes a constant string wide whenever string maps to Unicode. So by using this underscore uppercase D macro, we'll assure that our string, hello C++ Builder 10 Seattle string, is a Unicode string. And in this second application message box call, we'll output the content of the edit box. So we could take this code and we can compile it on older versions of C++ Builder, and it should all just work fine, with the exception of trying to display Unicode characters in an ANSI string based application. We saw in that case you're going to get question marks for the output, but otherwise this app will work fine. Let's run the app again, and this time we'll look at how the application message box behaves. So in this case we're still running with underscore teacher maps to ychar underscore t. So when I click on application message box, we see that the app works fine and outputs Unicode characters fine. So that behaves as expected, so that all works great. So the last thing I want to do with this app is once again change the project options of underscore teacher maps to, and let me put this back to char, and then we'll rerun the app. So now let me rerun the app, seeing what this does to the application message box. So now with underscore teacher maps to char, if I call the application class message box, we see that the literal strings still display fine, and we also see that the Unicode characters also display fine. So even with underscore teacher maps to char using the application class, which is in the VCL, the Unicode text from the edit box still displays OK. So that's great. Earlier in this presentation, I mentioned a blog post on migrating legacy C++ Builder apps to C++ Builder 10 Seattle. So here's one of the tips that talks about, should you just go ahead and replace all occurrences of string with ANSI string? We believe it's better to not just replace all occurrences of string with ANSI String, but instead define these two functions and then use them whenever one type is returned and the other type is required, and vice versa. And with these two functions, we're using these two Windows API functions. One's called the wide char to multi-byte, which converts from UTF-16 to the encoding of your choice, such as UTF-8 or any of the various ANSI encodings. And the other one is multi-byte to wide char, which converts from the encoding of your choice to UTF-16. And you can look at the Microsoft documentation on these functions. Let's next look at how do I deal with loading and saving of Unicode items. So how do I work with the encoding and the decoding? So for example, if you have a list box, how do you save and load the items from a file? Well, the load from file and the save to file methods, you now have a second parameter, which is the T encoding class. The T encoding class has a static property where you can specify the encoding, either ASCII or UTF-8 or Unicode or Unicode Big Indian. And if you look at the T encoding class, you'll see it has different field types like default, UTF-8, UTF-16 with Big and Little Indian and byte order mark support. So let's run an app and see how we can use T encoding to save to file and load from file. Here's a VCell app with an edit box and a list box. So let me run this app. So with this app, I can add and delete strings from the list box. I can save the items in the list box to a file, and I can load items from a file into the list box. So I have an external text file with Unicode characters, then I could load into the list box. So if I click my button, load from file, it loads some sample Unicode character strings into my list box. And if I select one of these strings from the list box, we see it nicely gets displayed on the caption property of a T label. So why can it do that? Because the VCL is fully Unicode enabled. That's why. So that's cool. So how do we do the load from file and save to file? Well, if we look at load from file, we look at its method, we will see that this method comes from the classes unit, and in this unit there are declarations for load from file and save to file methods for components that contain T strings. Looking at the methods load from file and save to file, we see that it now has a second parameter, which is the T encoding class, and the T encoding class has a static property where you can specify the encoding, either ASCII or UTF-8 or Unicode or Unicode Big Indian or Unicode Little Indian. And if we look inside of this class, we see that it comes with all these different types of encodings that we can use. And this class also has a bunch of functions that are used inside of the encoding as well. So this app, we're using UTF-8 encoding. Now, I'll mention if you don't supply the second T encoding parameter, then it's a null pointer, and in the runtime, if it sees a null pointer, it will use default encoding, and default encoding will be whatever the desktop you are running on, such as a Japanese desktop or a Chinese desktop or a USA desktop, or whatever you set the code page for your application, then it will use that encoding. But if you want to control it and you know you are going to put Unicode characters, let's say into a list box or a memo or a database memo, or you're dealing with Unicode characters in a database, in a text or a blob field, then you want to take control of the encoding. For additional tips and techniques on migrating your legacy C++ Builder code to 10 Seattle, start with the blog post I mentioned a few times called Migrating Legacy C++ Builder Apps to 10 Seattle on the community.embarcadero.com blog's website. So it offers tips and techniques like we see on this slide, plus many more. This ends what we had time to cover for this session on C++ Builder Unicode migration. Hopefully it gave you an overview of Unicode in C, C++, the VCL, and the Windows API, and hopefully it gave you an overview on how to migrate a C++ Builder application to Unicode and provided some useful tips and techniques for doing the migration. So for an overview approach for migrating your apps to C++ Builder 10 Seattle, here's what you can do for a minimal migration or a complete migration. And remember, Embarcadero is here to help. So let us know any Unicode migration issues you are having, and we should be able to help. For additional resources for migrating legacy C++ Builder, please visit the blog post Migrating Legacy C++ Builder Apps to C++ Builder 10 Seattle on the community.embarcadero.com blog's website, and you'll see all these additional resources to help with your migration. So hope this helps in your migrations. So once again, please let us know what specific C++ Builder Unicode issues you are having. Embarcadero is here to help. So thank you all for attending this session on C++ Builder Unicode migration.